Judgment Week into the Monday or Tuesday or Wednesday. Cinco, 5 bond, go bond. I lost my videos for number 5. So we are going to do this a little quicker than normal. And what I just mean by that is, once again, print this out. Go through the process of doing it by hand, PDF, JPEG. Remember, they want JPGs. See if you can get the JPG. Email it to me. It's just good practice. Okay, but go ahead and hit pause and see how you do with this problem. Okay, and then we'll talk about it. I'm actually not going to do it today, okay, because I lost the video. And so I'm going to go by it pretty quickly, but don't worry. We're going to go over it in detail. Come to Google Meets if any of it does not make sense, okay? So here we go. Find the velocity, find the acceleration, right? What would the velocity be? Will it just be the derivative? So you have to do the derivative of this top guy. Okay, I will make a little bit of notes. Take the derivative of the top guy, and there's a t and a cosine of 2 pi t. So that would be a product rule. So make sure you do the product rule there. And then this is a natural log, which is 1 over, don't you dare touch the inside. But then you take the derivative of the inside, right? But then you have to find the acceleration, which means you have to find the derivative of that. Crazy, okay? I'm going to show the answers to that right now, and then we'll talk about the other things. Okay, so there's v of t and there's a of t. Obviously, a of t gets pretty crazy, but you know what's cool about a of t is that you have these two guys that you can combine, right? Same exact thing becomes negative 4 pi sine of 2 pi t. Okay, and then the nice thing about this, the bottom part, which is the 1 over, it ends up being just t to the negative 1 for the velocity. So when you take the derivative of that, not too bad. Okay, let's go back to this. C, determine if the particle is speeding up or slowing down. Remember, to determine whether it's speeding up or slowing down, that means we're going to compare velocity with acceleration at time equals 1/2. So if you did that correctly, you got a velocity to be negative 1. You got an acceleration to be 2 pi t. And the important thing there is velocity is less than 0. Acceleration is greater than 0. So if they're different signs, well, then that means that the particle is slowing down. So far, that's 3 total points. Okay, let's go to part D. Write but do not solve an equation using a single trig function. Determine the values of t for which the particle is at rest. Remember, the way we always find out if a particle is at rest is we want to know when the velocity is equal to 0. And they want us to involve a single trig function to determine these values. Well, how the heck would I do that? Well, velocity you would set equal to 0. So there it is, set that equal to 0. And then what you would do is you would just subtract that cosine over, divide by the negative, and you get this. Okay. Now what's interesting is you could divide that cosine 2 pi t on both sides. And if you did that, you would get sine of 2 pi t over cosine of 2 pi t, which would be tangent of 2 pi t. And then what they did here in this part is they took this guy and they brought it over to the other side. Obviously, there are other answers you could get for that, okay? But that would be what we call a singular trig function, okay? And it would give you full credit for that, okay? And then part E, what is the value of k such that the velocity of the particle is continuous? Well, we all know for continuous, that would be the limit, right, as we approach from the left and from the right. So you'd have to make sure you have all that. There we go, 1 from the left, 1 from the right, which would have to equal the function value. Okay, and if you do all of that correctly, you get this statement right here, right? Cosine of 2 pi would be 1. Okay, you plug in the 1, you get the natural log of k. Okay, and if you solve that correctly, right, that'd be log base e to the k, which would be e to the first equals k. So there you go. So that would mean that's what k would have to be for it to be continuous. Nice and easy, Japoneasy. Please come to Google Meets because I miss you guys. We're 1 week away from this test. A week from today. Let's do it. Okay, it's your last week. Cram it in. come to Google Meets. I will answer and stay with you for as long as you have questions. But let's get it. Alohas.